potentiometer. So potentiometer is basically a device by which we measure the potential difference comparing the EMF of two cells, or we can calculate the internal resistance of the cell. So basically this is a device by which we calculate internal resistance. We can compare the EMF of two cell or the potential difference across the wire. Now let us consider this is a battery plus, and this is also plus. Here is we connect a galvanometer which shows the deflection when current is flowing in this. Now for this battery direction of current is this, for this battery current direction of current is this. Then what will be the actual direction of current for this? So if potential is more here compared to this, then current will flow in this direction. And now if potential is more here compared to this, then current will flow in this direction. But what happens when the potential is same for both battery, both cell? So if potential is same, then there will be no current, because current will flow whenever the potential difference. But what I am saying, potential is here is same and here is same. Potential across this terminal is same. Then current in this galvanometer is 0 and it will shows no deflection. Okay, so we can say that potential of this is balanced by this, and if we know the potential of this battery, we can easily say that what will be the potential of this. Okay, so these types of device require no current. Here Ig is equal to 0, so we call this is no current device. This is no current device. Okay, so now for calculating the potential difference, we have a device that we call voltmeter. So now if we have to calculate the potential difference across this resistance, then we suppose I current is flowing in this circuit. Suppose here I is 5 ampere and resistance is 10 ohm. So for calculating the potential difference across this, we put a voltmeter. So actually if 5 ampere current is flowing in this and resistance is 10, then V is equal to V, we write actual is 5 into 10. This is 50 volt. But for operating this, for operating voltmeter, it requires some current. Then from where it gain current? Answer: if 5 is flowing in this and if we connect V, then in 5 some current is flowing to operate voltmeter. So now current is 0.4 ampere, 4.9 ampere. If now we calculate the potential difference by voltmeter, this is 4.9 into 10. This is equal to 49 volt. But what is the actual potential difference across the resistance? This will be 50, but our measurement is 49. It means there is an error. And whenever we calculate the potential difference across across resistance or any resistance by voltmeter, it will always less than the actual value. So V by voltmeter is always less than actual value. Why? Because to operate this, it requires some current. So this is the advantage in this types of device, that it requires no current and accuracy is more. and it gives the accurate value of voltmeter. So in place of voltmeter, we use this types of device, that is no current device, and that we call potentiometer. Okay. So now principle of potentiometer. Principle of potentiometer. So it works on the principle of potential gradient. So what's about potential gradient? It is similar to the velocity gradient, the velocity per unit length. So for example, this is a wire, and here V is equal to 10 volt, and here V is equal to 0. Then and now this is L. Then for L length, potential drop is 10 volt, from here 10, and 0 minus 10, or 10 minus 0, this is 10. So for L length, potential drop is 10 volt. Then what will be the potential difference for unit length? This will be V by L. V by L is the potential drop for unit length. So this is called potential gradient, that potential drop per unit length. So it will denoted by rho. So potential gradient is V by L. Okay. Now construction of potentiometer. Construction. It is basically consist of a wooden block. This is a wooden block. Wooden block, and here is a screw for our connection, and now a resistance wire is connected in such a way okay, like this. So like this. Okay, so for our connection, we can write this like this. This is, and this. Here is a meter scale, which is of 1 meter. So this is 1, 2, 3, 4, 5 meters wire, and this wire is the resistance wire. So this is actually a single wire. This is of 5 meters. Here is a battery or illuminator that is a source of DC current. So this is we call source, and here another battery is plus of first battery is connected with second, that we discussed before. So now here is a switch according to my use, whatever you can use. Okay, and here is a wire, and here galvanometer is here, and this wire is connected with jockey, by which we search the null point. So okay, is to search for null point. What is null point? Null point is that when current is zero, it means there is no deflection in the galvanometer. So these are the construction of potentiometer. Okay, one question is more that why you use 5 meter of resistance wire? Answer is that if we have to calculate V, this is equal to rho into L, and for potential gradient this is V upon L. If now L is equal to, sorry, this is we write V is equal to 10 and L is equal to 100, simply okay 10, so this will comes to be 0.1, and now L is 1000, then what will happen for this potential difference? 0.01. This is 10,000 millimeter, then this is 0.001. What we will see that we will get more accurate value of rho. So to get more accurate value of rho, length should be more, and if length should be more, our potential difference is more accurate. So for this purpose, that we call sensitivity, that is sensitivity is more when rho is less, and when rho is less, when length is more. For this purpose, to calculate the accurate value of potential difference V, we take uh, as I can take the resistance wire for 5 meter, 7 meter. What can I take? So thanks.